Hello everyone, how are you doing? Let me trust you're doing good. Welcome once again to our tutorials for today. Today we are going to discuss about the laptop power supply or a laptop power sequence. For example, this diagram it shows how the voltage enters into the laptop motherboard from the moment you plug in your adapter or from the moment you plug in your battery. So this is the voltage coming from the battery until it reaches the CPU of the motherboard or the GPU of the motherboard. Before we continue, I'd like to request you, in case you haven't subscribed to this channel, please subscribe to it so that we can grow together. And again, you will not miss our tutorials. We shall be uploading a lot of content about the laptop repair. Already we've done some videos about the introduction to laptop repair, the safety methods and precautions in laptop repair. We've discussed about the equipment, that is tools and equipment which are used in the laptop repair, and so many other contents which are on the way coming. So please, if you haven't subscribed to this channel, please, I'm bleeding with you. Please subscribe to it. So before, to cut a long story short, I'd like us to start to discuss about this diagram. This is the diagram which shows how the voltage flows within the motherboard. First, we will have a power adapter here, which supplies the 19 voltage. This voltage is being supplied from the power adapter or AC power adapter. It's called AC because it supplies the alternating current from the wall socket, that is from the main power supply, from the main socket. Before it enters into the motherboard, it is converted to the DC. So it means this voltage which is used within the motherboard is the direct current, that is DC current. So this is the port of a laptop. This is the power port or the DC jack. This is the entrance of the power coming from the power adapter. It goes past this component here called power inductor. It is BL1. This is BL1. Some other laptops, instead of using the power inductor, they normally use the power fuse. So we'll have BF1 for power fuse. So this is a power inductor. Past the power inductor, we will have the first component called BQ1. The BQ, this stands for the power MOSFET. A MOSFET is a special transistor which is responsible for switching power. So whenever you see a component labeled Q or PQ, it means that is a MOSFET. So this BQ1, this is a power MOSFET, power MOSFET 1, PQ1. We love power MOSFET 2 or PQ2. Most motherboards, they have some components labeled. Some motherboards, their components are not labeled, so it's not mandatory that you find the component which has been labeled for you. So you might find this MOSFET instead of PQ1, it is written just Q1, or sometimes they write just BQ100 or Q100. Yes, in case you see a component labeled that way, just know that is a MOSFET. A MOSFET is a special transistor which is responsible for power switching. So in short, these are the switches. These are the power switches. So this component here, it switches power from this point to this other point. So the MOSFET contain three parts or three sections. It has a drain. So this side of the MOSFET is called drain. Then the other side of this MOSFET is called the source. Then we have the gate. So this MOSFET have the gate at the opposite. So meaning the pin number 1, we shall have a pin number 1 here. And then the source of a MOSFET has 3 pins. So we'll have the 3 pins here, 1, 2, 3. Then the 4th pin is the gate. And the gate is a pin which sends the signal or receives the signal from the control IC. Every MOSFET within the laptop motherboard has a control IC. Yes, this MOSFET does not switch power by themselves. It needs the assistance or the help of a control IC. So each and every MOSFET within the motherboard, it has a certain control IC. For example, the control IC for this MOSFET 1 and MOSFET 2 is this IC here called the BQ. The BQ is the charging IC. In other words, this is a charging IC, and we have several of them. The reason we called it BQ because you have several number of the BQs. For example, here I just put down some few. We have BQ24780S, you have BQ737, BQ735, you have BQ736, you have BQ25700, and so on and so on. So we have several of them. That's why I decided to just use the BQ to represent that charging IC. This BQ it is used widely, it's widely used. However, this charging IC is used by the older generation laptop, that is generation 1, generation 2, generation 3, generation 4. From generation 5, they upgraded from the BQ, they put what's called the interseal. So you might have interseal IC. If you see an interseal IC, it means that's still a charging IC. However, that IC is majorly used by the laptops which uses Type-C as well as any other pin, that is the blue pin. In case there are some other laptops which uses support the Type-C, there are some laptops which use only Type-C for charging. So those laptops have what's called the TPS. TPS is the charging IC for those laptops which uses the Type-Cs. And those ICs which are used to control the Type-C ports are smart ICs, meaning in case you use a fake the Type-C adapter, it might sense that adapter is not the original one, and it might short that IC. So you need to be careful whenever you're using Type-C adapters. So again, once you have the voltage which has been switched from this point of this IC to the other point, it is sent to the second MOSFET or the second switch. Once the voltage arrives here, the same control IC receives a signal that the voltage has arrived at this MOSFET 2, and that's this IC commands or instructs this MOSFET to switch 19 to proceed. So at this pin here, we'll have 19 voltage going into the motherboard, but the gate of this MOSFET will have 25 voltage. This 25 voltage is normally used to charge the battery. So this voltage will be sent into the battery to be used in charging the battery of a laptop. Then from there, you'll have a voltage going past this current sense resistor. So this is called current sense resistor or power resistor 1, PR1. This resistor senses the amount of current which is going into the motherboard. In short, it controls that current. In case you have excess current which has been allowed to come from this side of this power supply, this current sense resistor will sense that current and gives the signal back to the BQ. Then the BQ will control the current flow within this phase. So this is called phase 1 of power supply. From here, after this current sense resistor, then you come back from here. Then all of these other components which are there before here are called the phase 1 component of power supply. Yes, and it is controlled by this charging IC. So this charging IC is what is responsible for power flow from here until it reaches this other side. From there, the voltage will flow. Then we will have the first step down. So this is the step down 1. This step down 1 we will have the voltage which has been stepped down, that is 3.3 voltage, and then we will have 5.0 voltage. So we normally call this one always on voltages. Why do we say so? Because these are the voltages which are available at the all the states of a laptop. We have what's called states of a laptop. That is from the moment you plug in your power adapter until the moment the laptop is fully powered on. So those are the states. We call the states. So these voltages, you must have them for your laptop to be confirmed it has power. So those laptops which you say it has power, it's not powering on, they must have the main power line, or the main power, which is 19 voltage, and it must have these two voltages, that is 3.3 voltage and 5.0 voltage. This 3.3 voltage is sent to several parts of the laptop. Again, this is the voltage which is used to initialize the powering on of the processor. Yes, so this 3.3 voltage can also be sent to initiate the powering on of the processor. So meaning without this voltage, without the 3.3 voltage, it means you might not have your processor powering on. Yes. Same case with this one. This 5.0. Without 5.0, this 5.0 voltage is sent to initialize the powering on of the PCH. So in case you miss this, in case there is no this 5.0 voltage, meaning the PCH will not power on. And the PCH is a chipset which control the communication between the processor and the RAM. So in case the PCH is not powered on, meaning there will be no communication between the processor and the RAM. Then after this step down, okay, maybe we can discuss more. I can give you some examples where this 3.3 voltage can cause. Here, down here, I wrote some few components within the motherboard which needs this 3.3. So this 3.3 generated at this circuit is sent to not limited to these components. So these are just but a few components which need that 3.3. One, we have SIO. SIO, this is a system input output chip. So this is a chip which controls the input and output system of a laptop. We have the BIOS. The BIOS or UEFI chip. The BIOS, this is a basic input output system. So this is a chip. This is a chip within the motherboard which contains a firmware which ensures the hardware system of a laptop communicates with the software system of a laptop. You have the network card. The 3.3 is sent to the network card. You have audio IC. This is for sound production or the conversion of digital sound to be amplified by the speaker. You have the switch. The switch also needs 3.3. Then you have the screen. The screen needs 3.3 for the backlight lighting, and again it needs 3.3 for the data lighting of the screen. Again, here the 5.0 voltage, those 5.0 voltage is sent to the HDD or SSD. These are the storage devices within the laptop. You have the speaker, the fan, USB ports, audio ports, touch pads, yes, and so on and so on. So these are the, in fact, and again the keyboard. So the 5.0 voltages are sent to these components. Again, that 5.0 voltage is sent to initialize the powering on of the BCH. Higher, maybe you can go back a little bit here. You can see these inductors. So here, this IC is what controls it's what step down that voltage from 19. So at this particular site of this IC, we'll have 19 voltage. But the output of that IC, that is from here, we will have 3.3. However, that 3.3 is not yet controlled. So we will have an inductor which regulates that 3.3. By the time we have an actual output of this circuit, which is 3.3, this is now regulated voltage, which is now sent to these components. Then from there, as you can see, this inductor here it is written 1R5 915. This inductor also is written 1R5 915. What does that mean? It means these two circuits are related in one way or the other. They are family. In fact, they are called a family of 3 and 5. Yes, and without either of these voltages, your laptop cannot power on. In fact, in case you're missing maybe 3.3 and you are 5.0, that laptop will be considered as no power. Yes, even if you have one voltage, it still means you have no power within your laptop motherboard, and we will treat that as no power issue. Yes, but in case you have the two voltages and you have the main line, obviously you will have the main line. Once you have this one, it means already you have the main line, which is 19. In case you have those voltages, it means your laptop motherboard has what? Has voltage. However, it is not powering on. So we will treat that one as not powering on, not powering on case. So this one, you see, I wrote as section A. This one is A. So this circuit, I referred it as A. We will have B here. So don't get confused. So this other circuit here is another circuit on behalf of this one. So this circuit, it is used with the very latest generation, that is from generation 3. So this circuit represents a motherboard for generation 3 because it contains the PQ and it has this kind of circuit arrangement for 3.3 and 5.0. Very older generation, that is generation 1, generation 2, they love this kind of arrangement. So instead of this one, for example, instead of this one, we will have something like this. You will have an input circuit. An input circuit, it contains two MOSFETs or two switches. As you can see, this switch is PQ300, this one is PQ301. The output of this is 3.3, and we have 105. So this one again, you have BL500, PQ500. These are two MOSFETs which switches the 19 into 5.0 voltage. Regulated by this, and it's sent into the then you will have the output from there. So I believe at least you're getting something. I know, however, you might not fully understanding, but try to pick something out of our discussion. Then from there, from the first step down, you will have the second step down. So these are second step down voltage. This second step down, you will have the BD controller. Then you have inductor. Then we will get the output. The input of this circuit is 19 because that's the main power. Then the output, we'll have the output voltage depending on the type of RAM which that laptop is using. Yes, we have several types of RAM as I have written here. We have DDR1 or PC1, DDR2, PC2. Yes, in case you have DDR2 or PC2, that means that's the same thing, right? Yes, DDR1 is also for PC1. DDR2 also PC2. DDR3 also PC3. DDR3L also PC3L. So never worry. So these types of RAM consume different types of voltages. Yes, this DDR1 uses a lot of power, so they perform slower than the rest of the DDRs. So for example, DDR1, in case you're using DDR1 here, we will have an output voltage of 2.5 voltage. So meaning the output of this circuit will have 2.5. The output of DDR2, in case we have DDR2 RAM here, we will have a voltage of 1.2. Again, on top of that, the voltages for RAM, it contains two categories of voltage. We have what's called operating voltage and terminating voltage. I discussed earlier what is the difference between the two voltages. In my previous video, I explained all about those voltages within the RAM. Yes, in case I had DDR4 here, I would have had what? 1.2 voltage. So meaning DDR4 uses lesser power than DDR3L or DDR3 or DDR2 or DDR1. DDR5 or PC5. PC5 uses very less power. So PC5 uses 1.1 while PC4 uses 1.2. You can see there's a difference between them. So that was step down 2. We last step down 3. Step down 3 is what this is the circuit which supplies into the PCH. We have 1.0 voltage which is sent to the PCH. We also have another step down, the same voltage which will be sent into the PCH, that is 1.05. As you can see, these voltages goes directly towards this chipset. So within the CPU, this is a CPU. So within the CPU, we have two main chipsets. The chipsets are the PCH and the processor. And again, because you can see here, I wrote CPU, then something to do with iGPU. This is called integrated GPU. This one is available with the laptop which doesn't have dedicated GPU. In case your motherboard is not having the dedicated GPU, it will have integrated. So meaning within the CPU, we'll have iGPU. That's why we need so many voltages within that CPU because there are so many activities happening there. There are so many other components within that CPU which need different types of voltages. That's why we'll have several voltages going towards this CPU. For the PCH, under the PCH, we will have the north bridge and the south bridge. The north bridge uses a certain voltage, the south bridge uses a different voltage. That's why you can see we have more voltages going in. Same case with the processor. Within the processor, we have the processor itself, we have integrated GPU, and so on and so on, and other components which needs power within the CPU. That's why you will have several circuits supplying to the CPU. From there, same case applied to the dedicated GPU. This is dedicated GPU. You can see there's more than one circuit going in. Yes, this one, as you can see, even these coils are the same. So this coil is 2R1, 2R1. So it should have been 2R1 100, 2R1 100. It means these are the inductors which apply the same voltage towards one component, or they are related. Same case to this one. As you can see, this is R15 115, R15 115. So that R15, it means that inductor, the output of those inductors are almost the same. It's applying a voltage to the same area. Same case to this one, which supplies the voltage with the PCH. You can see these inductors are written R68. R68. Yes, because they supply the voltages to where? To PCH. Then here, so since we have the CPU, it has its own memory separately, that is the RAM. So RAM is the memory for the CPU. Here you have the GPU. This is the dedicated GPU. Dedicated GPU, it contains its own memory. So this called the VRAM. The VRAM, these are the memory for the GPU. So these VRAMs also store the data or images, videos for the GPU. Then the GPU processes those data and sends back to the CPU to be sent to where? To screen. Right? Yes. Let me trust at least you understood something. If you have not, please feel free to contact us, and or you can comment at the comment section. In case you have any question, I'll get back to you. I'll explain to you. Yes. Let me trust. So far, so good. We are heading somewhere. I know you will not understand everything within day one. It takes process. It takes some time. However, it will not take much long time for us because I'll be sharing a lot of content day in, day out. So please subscribe to this channel so that you might not miss our tutorials. Again, this course is not hard. At the same time, it's not easy. It's about you to be passionate. Yes, you need to be passionate and you need to love doing the work. Though you need to love doing this learning. So guys, thank you so much for being patient with me, and I really appreciate you guys. Let's grow this channel together. Let's grow together as a family, and I know we will reach far. So again, we do the laptop repairs uh, here in Nairobi, and we also teach. In case you're interested in learning, you can contact me. Then we can see how it goes. We do teach, and then we do repairs. So in case you know someone who has a problem with his or her laptop, please feel free to contact us. We might be able to help. So thank you so much, guys, and see you in the next video. Bye bye.